nuclear pore. This is the endoplasmic reticulum, and the endoplasmic reticulum is there's a smooth endoplasmic reticulum and there's a rough endoplasmic reticulum. Why does the rough endoplasmic reticulum called the rough endoplasmic reticulum? Because it has ribosomes attached to it. Excellently. What about the ribosomes who are attached to the rough endoplasmic reticulum? Compared to the free, we have two types of ribosomes. Some ribosomes attached to the rough endoplasmic reticulum, and some ribosomes are free floating, swimming in the cytoplasm. So what's the difference? Why do we have two kinds? Why not just one? Why are there ribosomes on the rough endoplasmic reticulum? Why not ribosomes on the Golgi body? Why not ribosomes on the nucleus? Why not ribosomes on the lysosome? Why no ribosomes on the plasma membrane? Why it's gotta be just the rough endoplasmic reticulum? There's a reason. The rough endoplasmic reticulum is gonna, ribosomes in the end, they're gonna be making proteins. Ribosomes in the end, they're gonna be making proteins. Whether they are attached to the rough endoplasmic reticulum or whether they are free floating. In the end of the day, whether you are on the rough endoplasmic reticulum, whether you are free floating, in the end of the day, you're gonna be making proteins. But the proteins that are made on the ribosomes, on the rough endoplasmic reticulum, the rough endoplasmic reticulum is going to stick a sticker on them, a sequence, signal peptide sequence. When the Golgi body reads that sequence, it knows this protein is to be shipped out internationally. It must go outside the cell. It must leave the cell. But the smooth endoplasmic reticulum doesn't make any proteins. The free-floating ribosomes, the protein they make is just going to be used locally inside the cell. See, that's the rough endoplasmic reticulum. The smooth endoplasmic reticulum important for